Hi, everybody. Welcome. Ben Pouladian here of BEP Research. I'm here live at GTC 2026 in San Jose with two of NVIDIA's finest. We have Dion Harris to my left. He's your Senior Director of HPC and AI Hyperscale Infrastructure. And newly joining NVIDIA from Grok, we have Senior Manager of Product Marketing Accelerated Computing, Stuart Pitts, on my far left. And we're just going to have a conversation about the future of data center, how Grok maybe was a missing piece for inference and how that all came about, and where we see the future of AI and data center and like where that's going. Because if you're on the show floor here, it's just the energy is amazing and it's just so much going on in this world. And I feel like people that aren't here don't really realize the scale and the magnitude of like what's going on. It's pretty wild. Yeah. You have to kind of see it yourself. So the first thing I wanted to ask you is like, we talk about AI infrastructure like it's like an abstract, like weird thing. What's like the most mind-blowing thing you guys ever experienced or seen when you've gone to one of these actual data centers? Because I still haven't gone one yet to actually see it. So like, what have you seen?
Well, I think you certainly get an appreciation for the size and scale and scope of these AI factories that are being built. When we're talking about AI factories that are on the order of hundreds of megawatts, multiple gigawatts, these are some of the largest investment infrastructure physically that has ever been developed by man. When you look at just the number of cables, all the connection points, the servers, the networking, the storage, it's truly mind-boggling. If you ever get a chance to go into one of the data centers, bring your earplugs first of all, but you can walk for minutes in any direction and still be in the midst of what's being built. So it's pretty incredible.
Wow. How about you, Stuart?
I think similar to the scale, I think you hear about this, but what you don't believe until you see it is the sheer speed that these things are getting built out, right? Like, when has there been an industry, right, in recent decades where the scale and speed of construction and deployment is happening? It's absolutely perspective changing to see it in real life.
So yeah, hopefully I can maybe get an invitation to one of these data centers, maybe Abilene, Texas. I heard it's like far away place in the middle of Texas. Maybe I'll go check it out one day. But the talk of yesterday's show and keynote is obviously Grok and the new LPU chip with this new unlock for pre-filled decode to basically speed up inference by about 35 times. So tell us a little bit about Grok, Stuart, and how you got to the company. You were previously at Meta and Microsoft, and like I heard it was like this shotgun journey, and then 3 months later there's like a chip, which is like crazy because the deal got announced. I believe it was Christmas Eve, right?
Yeah, that's right. It was a wild Christmas Eve for sure.
That's right. I was like, what? NVIDIA's buying Grok?
Right.
It's like I fell out of my chair and I was just like, I'm like, what's going on? And like I was just trying to piece it all together and just excited to hear your perspective of like what happened.
Well,
in that time period.
Grok had been partnering with NVIDIA for a while before this deal came to be. And what the whole purpose, the whole sort of genesis of why NVIDIA Grok started working together was this hypothesis of, can we pair the unique strengths of a GPU with HBM and the unique strengths of a compiler-driven SRAM chip together and create a whole new category of computer. And that's exactly what we announced yesterday with NVIDIA Grok LPX. It's a rack scale accelerator. It pairs with NVL72 and the Vera Rubin supercomputer to supercharge inference that's not just fast, it's intelligent and delivers, as you mentioned, up to 35x the output of a NVL72 system.
But how did you all this like? Literally, I remember the acquisition was like on a Tuesday, and then on Monday I saw on Twitter Sonny and the rest of the guys had like their NVIDIA backpacks. And I'm in the parking lot. I'm ready to go. Like the speed of execution that you guys work at, and even Jonathan Thomas said is like, we're a 400-person startup and we work pretty fast, and NVIDIA is like the same speed. So like, how has it been for you joining NVIDIA?
It's been fantastic. I think the teams share a lot of commonality in terms of just mission driven, get it done, right? Like Grok builds very fast. The teams at NVIDIA build very fast. And so we're building fast, many folks building fast here together. But I think one thing that a lot of folks don't realize is that the extreme codesign of the Rubin platform, the standard MGX rack, is really one of the key ingredients that has helped us move from 0 to, in less than 90 days, announcing this product that you saw yesterday. Standard MGX rack architecture, similar tray design, all liquid cooled, right? Just what you would get from an NVL72, but we're able to fuse that together with the unique SRAM architecture of the LPU and deliver a product that will ship this year in the second half.
Yeah. And I mean, that's really, like you said, some of the work that we've been doing to build out the ecosystem for these rack scale architectures over the last couple of years. A lot of the growing pains resulted in operational efficiency, and it resulted in know-how how to take a chip and turn it into a data center. I mean, that's essentially what we're doing. And so by integrating the Groq IP, and I'm going to correct you, we didn't acquire them. We acquired the licensing rights to IP. Ben, we got to be honest. No, I'm joking. But that notion that we're able to take the IP and quickly integrate it into our plans spoke to, like you said, the cultural alignment, the architectural alignment. In other words, having two die packaging-based technology that you can essentially put into a data center and infrastructure and have it run operationally efficient. That was another key element. But I think the cultural alignment is really what made it all work so quickly.
So pulling on that thread, I think the main topic, and most people and most investors underappreciate, is most semiconductor or regular investors are conditioned on a chip. So if you remember the x86 or the Pentium days, like Intel would show like Pentium.
That's right.
Right? And like it was that one chip, right?
Yeah.
And that was it. And then we make this margin on the chip. But that's not NVIDIA. And I have this challenge explaining to investors and friends, like, it's just not a chip company. It's like many chips, many software, and then at the same time, fully rack scale solutions of power and like all this stuff that goes into it. And like, oh my God, like this is like really complex and big. And if you go to the booth, you'll see that it's like, it's hard to replicate at scale what you guys are doing. So what do you think people are missing at times when it comes to what NVIDIA is doing, other than what I just mentioned?
Well, I mean, the notion of extreme co-design is something that we've been talking about for some time. And I think as we've looked at our architectures, as they've gone from Volta to Ampere to Hopper, each time we're thinking, how can we introduce more performance, more efficiency? And so what you quickly realize is you can only do so much with a reticle limit die. You can put them together, you can do chiplets, but again, you're only going to be looking at incremental performance improvement. To keep up with the demand we're seeing, you need X factors. And that's why we're looking at sort of what can we do with the networking, what can we do with the overall cooling and power delivery systems to make sure that you can deliver the most efficiency per watt. What can you do with software to make sure that you're avoiding computing altogether when you don't need to deliver tokens quicker. So it's having that holistic approach to, like I said, create X factors, not percentage gains, to really get the power of that demand that we're seeing.
I see. And then going through all this, what are some of the bottlenecks that you see going forward? I think the biggest thing I see is NVIDIA's primed the supply chain to the max to make whatever it needs on the physical side, but then maybe the bottleneck is like actually getting land and electricity to do it, and people actually putting up concrete walls and digging trenches and running wires, and like that is, you can't automate that. That's like human capital. So is that sort of like one of the things that you guys see sort of limiting the scale and growth of AI?
Well, and I'll comment on this, I'll let Stuart jump in as well, but I think we recognize that we absolutely can't do that alone. Like, we need the entire ecosystem to be ready and prepared so that when these systems and chips and racks are available, they're ready to land somewhere and deliver tokens. So actually at the keynote, we announced something called our DSX AI Factory Reference Blueprint. And that is more than just sort of a digital twin blueprint technology. It is really giving the entire ecosystem, from engineering and design to power generation to mechanical, electrical, and plumbing, to all the builders who have to contribute to even folks like grid operators.
Right.
We're helping them understand exactly what they need to do to support, develop, and build and operate these gigascale AI factories. And so that, like I said, as we roll these technologies out, the entire ecosystem's ready. But that's exactly why we built that DSX reference architecture, to make sure that all of those other folks that you described, who actually have to put concrete in the ground and who actually have to stand up data centers physically, understand what they're designing to and what's the overall design objective. And so that is actually accelerating that process by leaps and bounds, but it's also making sure that that extreme co-design is taken even a step further, not just at the chip, network, and computing level, but at the physical infrastructure level as well. And that's why when Jensen describes that 5-layer cake, right, he always starts with energy, because we recognize you need that first. Then, of course, we have chips and infrastructures a part of that, the land, power, and shell that goes into that. And then once you have that, then you can build models and deliver applications.
Right.
So.
I think that kind of reminds me of the same types of tools you gave your suppliers also, right? So,
it's this. Yeah. I think NVIDIA its secret power is its ability to rinse and repeat core strategies.
Yeah.
If you look at what we did with accelerated computing, it started in gaming, and we said we want to go and empower all the developers, the folks who are building games, to leverage our platform. That's really what started GTC. GTC is a developer conference. Then we said, there's general purpose computing, like scientific computing applications, where we can empower CFD researchers and molecular dynamics researchers to leverage accelerated computing. And then AI came about. It was another approach to just saying, how can we empower the developers to build on our platform? And now at the data center level, we're saying, how can we empower the developers, both physical developers to build on our platform? And so it really is just a recreation and re-implementation of that same strategy, is empower the developers building a platform, and that will sort of accelerate the adoption.
Yeah, it's pretty remarkable to see all that stuff and how you guys are translating and giving these tools to all these industries. It's an amazing time with all that stuff. I think another thing that maybe that I kind of pulled away from the keynote yesterday is obviously Groq. The LPU is not going to be used on every Vera Rubin, but the whole idea is when Jensen had that chart of free tokens all the way to like medium, like to premium.
Yes.
It kind of gave me the whole idea of like when you go to T-Mobile and you want to get like a cell phone, you can get like the free like old iPhone, which is like free, or you can go get the iPhone 16 Pro with the higher data package and pay whatever per month. And that product segmentation on inference and speed, I feel like, is the next defining feature of the market, and people, I guess, haven't realized that yet. But I think that's kind of where we're headed, right?
I would love to talk about this. I'm glad you brought it up. I think you heard Jensen say that we've reached an inflection point for inference, but I want to give you my perspective on this, which is if you've vibe coded an app or hard coded an app yourself, and you've actually built an agent, you understand that an agent is really the new unit of intelligence. And when you think about inference, right, inference is the fuel for agentic systems. The problem is that fuel has got to be smart and performant, right? And it's like a race car. You wouldn't power a McLaren race car with 87 octane fuel, right? You need a new grade, a new category of inference to fuel an agentic system. And so what we're focused on, and I really hope everyone in the industry sees this, is that we've got to build tokens at scale, a new category of tokens that's extremely intelligent, right? Genius level smarts. We need a whole lot of it. Why? Because agentic systems use up to 15 times more tokens than singular purpose-built AI agents. And they've also got to be fast, right? They've got to be performant so that agents can deliver on the economic promise that they represent for each of us and for each industry. And so this whole notion that Jensen talked about of a new premium and ultra premium category of inference is really rooted in this concept of agents becoming the new unit of intelligence for this era of AI.
And I think, just to unpack the idea of intelligence, in that Pareto, incredible amount of work went into those slides, by the way. I'll just say that.
Shout out to the team.
Right. Shout out to the team that worked on that, because that a lot. But in that, it was interesting, the way we defined intelligence, it wasn't just speed.
Yep.
We talked about the size of the model.
Right.
So you looked at the sort of number of parameters, because that is very indicative of how well and how much intelligence the model can produce. Talked about the context length, because again, your ability to have a longer context produces better results grounded in what you're actually looking for. And so again, and then in addition to that, you also have the speed.
Totally.
Right? So you have size of the model, context, and you also have speed that's going to determine how intelligent and performant that token is going to be. So every token is not the same. And so you're like you picked up, it was all about how do you segment your data center workloads, because that's the other thing that's very true. No data center is running one workload.
Right.
Like they all have to do some amount of calculus to understand what their user base looks like. How do you optimize? How do you segment it to make sure that you're giving them what they need to deliver maximum value? So that's really what was represented there. And I think the other thing that is kind of implied, but I don't think many people have asked the question, which is, how does NVIDIA plus Grok equal something more than the two combined, than the two in isolation, right? And how do we get 1 + 1 = 3 out of those solutions? And a lot of that is in how you actually implement the disaggregated serving. It's not like we're just taking a GPU, we're going to do prefill, and we're going to do the decode on a Grok chip. We're actually looking at the entire model and seeing which parts are flop constrained, which parts are memory constrained, which part need lots of memory, which part needs high bandwidth. And then which parts need to talk to each other very quickly. So we're looking at the entire end-to-end model, layer by layer, and we're segmenting the model to fit the architecture.
And I just have one final closing question.
Yeah.
It's rapid fire. To me, when I saw the Groq LPU and the speed and everything, Jensen, for the longest time, has said that when people make these custom ASIC projects, primarily for inference, by the time they're ready to tape out, like they get scrapped. And to me, when I saw that chart and everything, I was like, what a waste of money. All these people are doing all these things. Like, will they ever catch up? Like, what is your perspective on my thoughts of that?
Well, I mean, there's a ton of room for innovation
Right.
in this category, and that's what we're focused on. Right. And I think what you've seen in less than 90 days since Christmas Eve, I think less than 90 days at this point since the deal was inked, you've heard from us, we've delivered a ton of innovation, not just on the hardware, on Dynamo, on the inference orchestration layer between GPUs and LPUs. So we're going to keep doing that. There's an enormous amount of innovation, right? I don't think any of us can predict in 6 months what an agentic system is going to look like. If we were, we'd be rich. And so we're just got to keep building. We got to keep building, and we got to keep delivering on the promise of this and make the value real for people.
Well, and I think our job is to make it as hard as possible for folks to catch up, because that annual cadence that Jensen talks about in the roadmap, that was unheard of years ago. Anyone building, much less a single chip, building an entire architecture that's revving every year, adding new dimensions, having software that helps orchestrate it all, that is something that is incredibly hard to do. But again, that's why NVIDIA is a special place in its ability to execute speed of light. And then I think with the addition of Grok, much like when we added Mellanox, very like-minded, very, very aligned. And I think it just helps the spaceship go even faster. So a lot of fun times ahead.
Well, that's all the time we have. Thank you for joining us. Thank you.
Thanks, man.
Thanks so much.
Thanks for having us, man. Appreciate it.
Have a great rest of show. Excited to
Likewise.
connect to you guys more and keep. We have the need for inference speed, so keep it running.
Absolutely. We'll have to share more later this year.
Yeah,
For sure.
thank you.
Exactly.
Thank you, guys.